We've been talking about t-tests, and one of the main assumptions of t-tests was that our population data was normally distributed. And I know I kept saying that the normal distribution is really common, it keeps popping up again and again and again. But not all data is normally distributed. And what happens when you want to do a statistical test on data that isn't normally distributed? We can't use those t-tests anymore. So instead we can use non-parametric tests. So if you want to do a one sample t-test on data that isn't normally distributed, what can you do? We can do a Wilcoxon signed rank test. And here, rather than comparing means, we are comparing medians. So the null hypothesis now is that the median of our data is equal to a specific value. And again, we have three alternative hypotheses. That the median is less than that specific value, that is not equal to that specific value, or that is greater than that specific value. And again, we have one-tailed or two-tailed, depends on which one we choose. So a Spanish politician disputes the claim that 50% of Spain's cities have less than 700,000 citizens. 8 cities are selected completely at random to test this, and these are the 8 cities and their populations. So now what is the question? Well, the question now is the median, because we're talking about 50%, okay, is the median equal to 700,000 like the claim says? But the alternative, because we don't know how the politician is disputing this, if it's greater than or less than, the alternative is that the median is not equal to 700,000 citizens. And therefore, this is a two-tailed test. We will choose a 95% confidence interval, as before. Now, in order to do this, we're going to use an online calculator. So let's go over to Google. So if I just type in Wilcoxon signed rank test calculator now, and I go to this top one. Okay, this is the one we've been using before. If I go take me to the calculator. So these online calculators, they always look like they seem to be doing a test on paid data. So how does that relate to our one sample data? Well, in the first sample, we are going to paste our city populations. And in the second sample, we're going to pair each of these to that thing we are comparing to the hypothesized median, which was 700,000 citizens. So now we are doing a paid test, but we kind of not. We are comparing the median of these to 700,000, but we're doing that by just taking 700,000 away from each of these, then comparing the median of the difference to 0. It's exactly the same thing. So now we're going to choose a significance level of 0.05. And now, I know I kept telling you, always select a one-tailed test. For non-parametric stuff, though, it's important that you do select a two-tailed test this time. So if we click calculate now, so it'll do a load of calculations, but you can see exactly what it's doing here. It's taken the difference and worked out whether it's a positive or a negative difference, and that's how it's working it out. It's exactly what I said. And now if we scroll down to the bottom, our sample sizes are not big enough for us to get a proper p-value out, but the non-parametric test can handle that, but it now just tells us whether it's significant or not significant. So in this case, the result is not significant at the 95% level. And therefore we cannot reject the null hypothesis. What if we wanted to do a two-sample t-test or an independent samples t-test, but our data was not normally distributed? What could we use then? We could use a Mann-Whitney U test. And this also has the name Wilcoxon rank sum test. So that looks very similar to the Wilcoxon signed rank test, but it's called the Wilcoxon rank sum test. But more commonly it's known as the Mann-Whitney test, but they are pretty interchangeable. You'll see both of these very commonly. So the Mann-Whitney test, we are comparing whether the median of the first population is equal to the median of the second population. And there are three alternative hypotheses, whether they are one-tailed or two-tailed. Now, the fact that we are using medians is quite neat. We don't necessarily have to think of it as ratio or interval data anymore. We can actually perform this on ordinal data. So let's have a look at an example. Mercedes and Porsche both release an electric car each, and Porsche claim that theirs is faster than Mercedes's. Top Gear hold a race to see which car is faster. So 11 Ferraris and 9 Porsches all set off at the same time, and they record the order at which they crossed the finish line. So you can see here, a Porsche came in first, a Porsche came in second, a Mercedes came in third, Porsche came in third, and so on. So this is the first people over the line, this is the last people over the line. This is ordinal data, but we can compare whether their medians are equal or not. And if their medians were equal, then not one is faster than the other. But if their medians are not equal, if one's bigger than the other, so we think that Porsche's median is less than Mercedes because they're faster, then the distribution of the ordinal Porsche data would be shifted over compared to the distribution of the ordinal Mercedes data. So now we're asking, the null hypothesis is the median position over the finish line of the Porsches equal to the median position over the finish line of the Mercedes? And because Porsche claim theirs is faster, our alternative hypothesis is that the median position over the finish line of the Porsches is less than the median position over the finish line of the Mercedes. So this is a one-tailed test, and we choose alpha is equal to 0.05. So in order to do this, let's go to an online calculator. But what is our data this time? Our data is the positions. So the Porsche positions are 1, 2, 4, 5, 7, and so on. And the Mercedes positions are 3, 6, 8, 9, and so on. So into Google, I'm going to type in a Mann-Whitney test calculator. And I'm going to use that same website we've been using before. So now we want to paste our positions of the Porsches into sample 1. So they came in first, second, fourth, fifth, and so on. And paste the positions of the Mercedes into sample 2. And choose a significance level, 0.05. And we were performing a one-tailed test now. So we click Calculate U. As we scroll down to the bottom, we will see this one actually gives us a p-value because we've got enough sample sizes, but both of these show that the result is significant, and therefore we reject the null hypothesis. So we reject the null hypothesis, and we can say that the Porsches came in faster than the Mercedes.